Hello, this is Sean Luck with www.free-academy.com. We're going to be doing a practice problem on the limits. Now, I've shown a graph here and should add this little notation. It's a step function, modified. It will go on to negative infinity on the left side. It'll stop at x equals 3, and then it will go up to the value of y equals 3, and then continue on to positive infinity. And we're asked to find the limits at various points. So let's dive right in and start with problem A. The problem A is asking what is the limit as x gets infinitely close to 3 coming from the negative side of f of x. That's what this little minus states. It's coming from the negative. And notice as we get infinitely close to x equals negative 3, we get the graph is equal to y equals negative 1. So the answer to A is negative 1, because the limit is the y value as you get infinitely close to an x value. Going on to do problem 3, it's the exact same thing, only we're finding x approaches 3 from the positive side. So the y value, as we get infinitely close to 3 from the positive side, is equal to 3. So that's our answer for part B. Now what makes C interesting is we're asked what is the limit as x approaches 3 in general. So this is no specification of whether we're coming from the positive or the negative side. What is the limit as x gets infinitely close to negative 3? Well, if you recall from our lectures, if you have negative 1 as your limit from one side and 3 from another side, then you have no limit. Does not exist. Your condition for having a limit as x approaches a of f of x is that the limit as x approaches a from the negative side equals the limit as x approaches a from the positive side. And if this condition is not met, then you do not have a limit. Moving on to problem D, part D, we're asked to find what is f of x, or f of 3. We want to find the value of f of x of 3. Well, these little holes here mean that there's no value at x equals 3 for each of these lines. However, we do have a point at x equals 3, and it's equal to positive 1. So f of 3 equals 1. So the limit approaching from the left is negative 1, the limit approaching from the right is 3. There is no global limit, and the value of the function at 3 is equal to 1. So we can get a lot of different answers out of a single problem doing limits. Now problem part E asks what is the limit as x approaches negative infinity. So as we get infinitely to the negative point side of the graph, what is the value of y? Well, these lines continue on to infinity in both their respective directions. So we're not expecting any type of change, and in fact it states in the problem in the book here that we should assume that the graph does what it appears to. So the value is negative 1 at all points less than 3, so we can assume that at negative infinity y equals negative 1. And the same story for f. As we get to positive infinity, we assume that the graph stays exactly the same, so this will be equal to 3.